Hey guys, welcome to my third video on factoring polynomials. So in this video, I'm going to show you how to use the formula for sum or difference of cubes. So this formula only works if you have a binomial that is a perfect cube, and each term is a perfect cube. So as an example, we have 8x cubed plus 1. The formula will work for it because 8x cubed is a perfect cube, and then 1 is also a perfect cube. All right, so that's what we mean by that. And it will also work for this binomial and this binomial. Okay, so let's talk about the formula. So the formula is a plus, so whenever you have a sum of difference of cubes, you're going to have two factors, one linear factor and one quadratic factor. So for the linear factor, all you have to do is take the cube root of the first term and then the cube root of the last term. All right, so cube root of the first term and cube root of the last term. Then to get the quadratic, you're going to need to take the square or square the first term, that's how you get a squared. Square the last term, that's how you got the b squared. Multiply these two and take its opposite sign. That's why you got a negative ab. All right, so if you follow that rule, this is very easy to follow. Let's take a look at the second example, a cubed minus b cubed. So again, we take the cube root of a cubed, which is a, cube root of b cubed, which is b. Then we take a, we square it, that's how we got a squared. Then we take negative b and square, that's how we got b squared. We multiply these two and take its opposite, that's how I have a positive ab. All right, let's take a look at my examples. We have 8x cubed plus 1, which is equivalent to, so remember, take the cube root of 8, and that's going to give me 2. So that's why I have a 2x here. Cube root of 1, which is 1. All right, next, quadratic term. So we take 2x and we square it. That's why we get 4x squared. We take the number 1 and we square it. That's why we get a 1. Then we multiply these two and we take its opposite. So that's why we have a negative 2x. So we could follow the same rule for 8x cubed minus 1. All right, so we have 2x minus 1 because cube root of 8x squared is 2x. Cube root of 1 is negative 1. Negative 1 and cube root of negative 1 is negative 1. All right, then we take 2x and we square it. That's how we got 4x squared. Take the negative 1 and square it. That's how we get a positive 1. Then we multiply these two and change its sign. So that's why we got a positive 2x. All right, so let's practice with these two. So the first one is 64x cubed minus 1. So remember, we're going to have a linear factor. I'm going to mark that red. And we're going to have a quadratic factor. All right, so in red, I'm going to think about the cube root of 64. And the cube root of 64 is 4. All right, so the first term is going to be 4x and then minus 1. All right, let's erase that. All right, then we take 4x and we square it. So when we take 4x and square it, we get 16x squared. Then we take negative 1 and square it, and we get a positive 1. Then we take these two and multiply them together and change its sign. So that's why I'm going to get a positive 4x. Okay, and there you have it. Once it's factored out, you can set it equal to 0. And you can figure it out. You can figure out the zeros from it being factored out. Okay, but the most important part is that you know how to apply the formula for the sum or difference of cubes. If you are solving for it, then 4x minus 1 is equal to 0. All right, 4x is equal to 1, and x is equal to 1 over 4. So about definitely 0.25. Okay, I'm going to show you the graph really quickly so that you can relate. So this is 64x cubed minus 1. So you could see that the x-axis there, it crosses at 0.25. And you also see that it doesn't cross the x-axis any more than that. And that is because this factor is actually going to be imaginary. So to prove it to you, we have b squared minus 4ac. So b is 4 and we square that. So 4 times 1 times it's not 1, it's 16. All right, so 4 times 16, 16 times 1. Okay, so that's going to give me 4 squared is going to give me 16. All right, 4 times 16 is going to give me 64. And altogether, that's going to give me negative 48. All right, so that's why it's going to be imaginary. So I can keep going to figure out what's my imaginary solution, but I really just want to show you how to factor this out first. Okay, so let's move on to the next. All right, so this is going to give me two imaginary solutions. So that's why you don't see it. on the graph. All right, let's look at my next example. So we have x cubed plus 64 is equal to 0. And again, if we're looking to solve for x, you can simply just, subtract 64 and take the cube root of that. But if we're looking for all the zeros, including imaginary solutions, you need to factor it out. Okay, so let's factor it out. We're going to have a linear factor, and then we're going to have a quadratic factor. So in our linear factor, we're going to have the cube root of x cubed, which is x, and then the cube root of 64, which is positive 4. Okay. Then we're going to take x and we're going to square it. So we are going to get an x squared. Then we have 4 and square, and we're going to have 16. Then we take these two, multiply them together, and take the opposite sign. So I'm going to have a negative 4x. Okay. All right, so now in this solution, we have x plus 4 is equal to 0, which is real. So I'm going to subtract 4 from each side. So it should cross the x-axis at x equals negative 4. All right, I'm going to test this out to see if it's real or imaginary. So I'm going to do b squared minus 4ac. So this is negative 4 squared minus 4 times a is 1 times c is 16. So this becomes 16 minus 64. We're here again at negative 48. So this is going to give me two imaginary solutions. Okay. All right, so we now know that the graph is somewhat going to cross the x-axis once at negative 4, and then it's not going to cross again. So let's take a look at the graph. So x cubed plus 64. So again, that's where it crosses the x-axis, and it doesn't cross the x-axis again. All right. Thank you for watching this video.